Hello students, welcome to M10 classes. First of all, I apologize because I couldn't make videos because I had to deal with an emergency and that's why I couldn't make videos. I apologize for that. Now without wasting time, let us start today's session. So today we are going to discuss about heating effect of electric current and its application. Today we are going to wind up this chapter electricity and in the next class we will further proceed to other portions of our science. So before going to heating effect of electric current, now let me ask you some questions. Have you ever observed before turning on any appliances, electric appliances, you might have touched it and you might have found it as its temperature is very less and it is cold. But if you're going to turn on and run the electric appliance for some time, you'll find that the temperature of its surface will gradually rise. You can consider a fan for your experiment. Now, why is it so? Now, whenever current passes through a conductor, some amount of energy is dissipated in the form of heat. Some amount of energy is lost in form of heat. And that is known as heating effect of electric current. Now consider if you are going to use only a resistor with a battery, which is the power supply, the current will pass through the resistor only and the entire amount of energy will be dissipated in the form of heat, and this is known as heating effect of electric current. Now let's come to Joule's law of heating. So as I have told you, if you are going to supply the current only through the resistor, heat will be generated in the resistor. Now, Joule's law of heating states that the heat produced in that resistor is directly proportional. First one, the square of the current for a given resistance, that means H is directly proportional to I square. Secondly, the resistance for the given current, that means heat is directly proportional to resistance. Third one, the time for which the current flows, that means H is directly proportional to the time. Okay. Now you might have observed that if you are going to turn on the fan for 10 minutes and for 1 hour, in case of 10 minutes the temperature would be less, and if you are going to turn it on for 1 hour, the temperature would be more. Okay. So from this Joule's law of heating we are getting that H equals to I square RT. This is the formula. But we can also derive some other formulas out of it. Let us see. H equals to I square RT. Now if you are going to separate I square IR, you are going to write it as H equals to IR into I into T, and from the Ohm's law you are getting that IR equals to V, so you will get H equals to VIT. You have got another formula. Now again, if you are going to replace I with V by R, what will you get? You will get V square T by R. So you are getting three formulas. Number one, this is H equals to I square RT. Number two, this is VIT. Number three, this is V square T by R. And what is the SI unit of heat? It's Joule. Now if you look at any electric appliances at your home, it has a particular power rating. You might have seen that the LED bulbs rated 9 watt. The tube lights rated 36 watt, and suppose fan rated 500 watt, electric heater rated 1000 watt. What is this watt? This is the power rating. What is power? In class 9th you have already read about power. Power is the rate at which work is done. Now what is electric power? The rate at which electric energy is dissipated or consumed is called electric power, and SI unit is watt. So what would be the definition of 1 watt? This is important. That is, it is the power consumed by a device that carries 1 ampere current when operated at a potential difference of 1 volt. This is the definition. Okay. Now what is the formula? Power equals to work done by time. So here the work done can be written as the amount of heat generated also. From the Joule's law of heating you have got heat equals to I square RT, VIT and V square T by R. Now putting that formula, you'll get P equals to I square R Vi and V square by R. Okay, now this is the formula, whatever we are going to use in the numericals. Now there might be a question. Now LED bulb in my room is rated 9 watt, but tube light in Papa's room is rated 36 watt. Am I saving more energy if both operates for the same time? Obviously you are going to save more amount of energy. That means 9 watt bulb, it will consume less energy in comparison to the tube light that is rated as 36 watt. So whenever you see suppose electric heater, it is rated at 1 kilowatt, that means it consumes more energy in comparison to the other electric devices. So always try to use the devices which have low power rating. Now students, you might think that how will you know about the power rating? What are the rating of the devices? In each electric devices it has a rating. Now here it is an electric heater. You can see a rating is given over here. Now in every electric appliances you will find this rating. First one, the power rating 1650 to 1960 watt. Here it is variable because you might have seen that in electric iron you can heat it as low temperature as well as at high temperature. So its power can vary. Secondly, the voltage at which it will operate. It will operate at 220 to 230 volt. Third one is 50 hertz to 60 hertz is the frequency of the electric current and electric voltage. So in India it is 50 hertz. So in each electric devices you will find those ratings. So whenever current flows, heat is generated and heat is dissipated. Actually it is a loss of electrical energy. But it has some useful applications also, which are going to see the practical applications of heating effect of electric current. So heating effect of electric current has many useful applications in devices like your electric iron, electric heater, electric kettle, etc. Now consider an electric heater. When you turn it on, it glows rapidly and produces a large amount of heat. But you might think that whenever you turn on the switch or turn on the supply, the coil heats up, but the cord doesn't. Why is it so? The cord which connects the supply to the heater is made up of copper, which has very less resistance. And the coil of the heater, it is made up of an alloy, which has more resistance. And from the Joule's law of heating, H equals to your I square R T. That means if the resistance will be more, then the heat produced will be more, and that is why the coil heats up rapidly. Now you might think that why are you using coil of the particular metal or alloy? Why can't you use just straight wire? Whenever you are making a coil, you are wrapping up of a long wire in a small area. As well as in the form of coil, the area in which the heat is dissipated is increasing, and that is why the temperature is rising faster, and that is why electric heaters has coil of alloy. And what is the alloy? It is nichrome. What is nichrome? It is an alloy of nickel and chromium. Next come to electric bulb. What is the concept behind electric bulb? How does it glow? Actually, in case of bulb, the light comes out because of heating of the filament. Now next come to filament. What is the filament used in the electric bulb? The filament of the electric bulb is usually made up of tungsten. It might be a question in your exams. And why tungsten is used? It has a very high melting point of 3380 degrees Celsius. Now electric bulbs are usually filled with inactive gases of nitrogen and argon. Why is it so? It is because nitrogen and argon, they are unreactive and they will not react with tungsten. Now suppose, can you use oxygen in place of nitrogen? No, because when you are going to heat or supply current through tungsten, it will heat up and will get oxidized and it will get damaged, and that is why you cannot use oxygen. Now let us see the picture of electric bulb. Now see, this is the picture of electric bulb. Here you can find the filament. It is actually coiled of thin wire of tungsten, and whenever electricity passes, the heat produced in the tungsten, now see here, the heat is produced in the tungsten and that is why it glows. Okay, but sometimes you might have heard that the bulb has become fused. What do you mean by it has got fused? Sometimes whenever you are going to use the bulb for long term, the tungsten gets weaker and it's get damaged like this. You can see in the figure, it has the filament is broken. And when the filament will be broken, electric current cannot pass through it, and that is why it is called fused, because it will not glow. Now let us discuss another application of heating effect of electric current, and that is it electric fuse. You might have heard about this. Suppose there will be rain and the supply to your homes will be cut off, and suddenly when the current supply is on to every home, sometimes you may find that in a neighbor's home electric supply is there, but you don't find electric supply at your home. Your father says, yeah, that fuse might be broken, call the electrician. Now what happens to the fuse and what is the use of fuse? Now see, electric fuse is a protective device which is used to protect electric appliances from getting damaged by high voltage and high current. Okay, now this fuse is placed in series with the device. Fuse usually consists of piece of wire of metal or alloy, and that alloy is basically of lead and tin of appropriate melting point, and it has a specific current rating. What does this mean? What is this electric fuse? What is this current rating, and how will it operate? Before going to know that, let us see the picture of fuse. Now students, see here, this is what you call a cutout. You may find it in your home in the what you call is your supply box, electric main supply. Okay, in that board you'll find this cutout. Now you see here there is a current rating, let's say 63 ampere. Okay, now what happens, what is there inside it? If you are going to open it, you'll find this, there will be a wire like this connecting. This is called the fuse wire. It has a appropriate current rating. It may be made up of a metal or an alloy. Basically the alloys have low melting point. Whenever current flows through this, let's say it has a current rating of 5 ampere, and suddenly a high current of 8 ampere will flow through this. So what will happen? This wire will be melted, and whenever it will be melted, as it is placed in series, it will break the circuit, and that current will not affect the other appliances. Now see here below in the figure, it is called a cartridge fuse. Now where will it find it? Now you might have purchased some extension boards of plastics which are prefabricated. If you are going to open it, you will find those this cartridge fuse, they are actually covered with glass tubes, and they have that is low current ratings. You may open the appliances or these devices and you can find this cartridge fuse. Okay, so students, whenever your fuse is melted and damaged, do not use any wire to replace the fuse. Call an electrician, let him replace it with a fuse of appropriate current rating, unless your appliances will get damaged. Now let us see a question. What is the appropriate fuse for an electric iron rated 1 kilowatt to 20 volt? So according to your question, the power, it is 1 kilowatt, that is equals to 1000 watt. Okay, now what is the voltage rating? Your voltage is 220 volt. Okay, now to what will be the appropriate current rating? That means you have to find I current. Okay, now you know that P equals to V I, that implies you'll get I equals to P divided by V. Now putting those 1000 divided by 220, you'll get approximately 4.54 ampere. Okay, now if you are going to get this 4.54 ampere current, so what would be the appropriate fuse for this? So you may take a fuse of rating 5 ampere. Next comes commercial unit of energy. Every month, at the end of the month, the electric department provides you with an electric bill that shows you how much electric energy you have consumed and how much you need to pay. Now, you might be knowing that the electric bill shows you have consumed, let's say, 87 units. What is this unit? This commercial unit of energy is 1 kilowatt hour, or that is called 1 unit. So what is the value of this 1 kilowatt hour? You may get question that convert 1 kilowatt hour into joule, or converts 1 unit into joule. So simple, 1 kilowatt hour, that means 1 kilowatt into 1 hour. Okay, and 1 kilowatt you have to convert it into SI unit, so it is 1000 watt, and 1 hour is 3600 second. Now by multiplying you will get 3.6 into 10 to the power 6 watt second, and watt second is nothing but joule. So you will get 3.6 into 10 to the power 6 joules. Now see here students, this is called an MCB, that is stands for miniature circuit breaker. Okay, now what is the use of this MCB? You might have seen that it is used in homes also. In case of fuse, if it is going to melt, you have to replace it, but here there is a simple replacement of this. In this case, in case of MCB, if the current becomes more than the rated value, it trips off. When it trips, it breaks the circuit and the current doesn't flow to the circuit and doesn't affect the appliances. Okay, and you don't need to replace it, you simply turn it on. If it becomes off, trips off, just turn it on and you'll get the electric supply. So it is an efficient replacement of this fuse. Now what is the rating here? You can see here this C32. This C32 means it has the current rating of 32 ampere. Now let us see some numericals. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. Students, I have told you whenever there is a numerical, always find out the data. So if it is 5 ampere, this 5 ampere is the current, so I equals to 5 ampere, and there is a 220 volt line, that means the voltage supply is V 220 volt. Okay, now and the time given is 2 hours. You may convert it into seconds, that is 7200 seconds. You have to first of all find the power, and the formula for the power is V into I, so you can directly multiply, you will get 1100 watt. Now what is the energy consumed in 2 hours? You may find it in joule, you may find it in watt hour also. Okay, now if you are going to find it in joule, you have to utilize the SI units. So the power is 1100 watt and the time is 2 hours, that is 7200 seconds. By multiplying you will get 7.92 into 10 to the power 6 joule. But it would be convenient for you to find it in watt hour or kilowatt hour. So again 1100 watt, and you multiply it by 2 hours, you will get 2.2 kilowatt hour. So this is the energy utilized or energy consumed in 2 hours. Now another numerical, find the electric bill for the month of April if two bulbs of 100 watt runs for 10 hours, two fans of 250 watt runs for 4 hours, and an electric heater of 1 kilowatt for runs for 2 hours daily, and one unit is rupees 3. So how to find it? First of all, find the energy consumed on daily basis. So first of all, consider bulb. So there are two number of bulbs, each of 100 watt, and they run for 10 hours. Okay, so by multiplying you will get 2000 watt hour is the daily energy consumption. For the fan, there are two fans, each of 250 watts and runs for 4 hours. You'll get 2000 watt hour again. And for the heater of one heater for 1000 watt and 2 hours, so the total energy consumption you are getting 6000 watt hour or 6 kilowatt hour. So as you know, 1 kilowatt hour is nothing but 1 unit, so you are getting 6 units here. Now what would be the electric bill? Now daily consumption, there are in the month of April there are 30 days. Each day you are consuming 6 units, and per unit you are getting the price is 3 rupees. Now if I are going to multiply, you will get 540 rupees. So this will be your electric bill for the month of April. So students, this completes this chapter electricity. If you have any problems in your numericals, you can write it in the comment section. I can get back to you. And let us see the formula at a glance, whatever formula you had read in this chapter. First of all, current is the rate at which the charges flow. So I equals to Q by T. Next comes your potential difference, is the work done to move 1 coulomb or 1 unit charge from one place to other. So it is W by Q. So W equals to VQ. Ohm's law, V equals to IR. And resistance, its formula is rho L by A, where rho is the resistivity. For the series combination of resistors, the total equivalent resistance RS equals to R1 plus R2 plus R3, like that. And for parallel combinations, 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3, like that. And the important formulas related to power and the heat consumed. Power equals to VI, I square R, and V square divided by R. H equals to VIT, I square RT, V square T by R. So these are the important formula, students. So learn it and try to solve the numericals. If you have any problems, you can get back to you. And thank you, students, for watching these videos. And like, share and subscribe. And in the next video I'll come up with a new chapter from chemistry. Till then, goodbye.